Nu eerst, hoe bouw je een achtbaan?
The roller coaster is the ultimate scream machine.
A roller coaster is the king of the amusement park. It's that machine that once you sit down in it and you're locked in, it's controlling your destiny for the next 2 minutes of your life.
In modern roller coaster design, the race is always on to come up with the next big thing.
Every park likes to have the bragging rights to having the biggest, fastest, or wildest roller coaster.
In the last 100 years, roller coaster technology has advanced at a dramatic rate.
It is actually safer to go and ride on a roller coaster than to stay at home.
Have we built the ultimate roller coaster? This is X in California, one of the most technologically advanced roller coasters in the world. Plummeting 200 feet at almost 80 miles an hour, X also twists riders 360 degrees forwards and backwards.
With X, when the seats start to spin, you can do the most crazy maneuvers you ever thought of.
It's an engineering miracle that pushes the human body to its very limits. It is the ultimate in roller coaster design. But how did we get here? The modern roller coaster had a rather humble beginning. Over 400 years ago in Russia.
An enterprising St. Petersburg showman discovered people would actually pay money to be terrified. He built wooden slides, covered them with ice, and would charge people to go down the hills on small sleds.
In Paris, they had little snow, so French showmen built wooden slides and small cars rolled down them. The roller coaster was on its way. And it was with the track that the modern coaster began to take shape.
The first modern roller coaster, one with undulating hills, was built in 1884 by a man named Lamarcus Thompson.
Like all roller coasters, it was powered by gravity. As the car ran down one hill, it gained enough momentum to climb the next. Thompson realized with extra hills, he could create an illusion of high speed.
There were newspaper reports describing them as going 100 miles an hour. But in fact, they went at about 4 miles an hour.
And these early coasters had a major flaw. At the end of the track, the car had to be lifted off and turned round to get back to the beginning. Within just a few years, designers had come up with a solution.
A circular layout so riders wouldn't have to get off in the middle of the ride.
Unfortunately, solving one problem created another. As roller coaster engineer John Roberts knows only too well.
A roller coaster is really quite a complex piece of machinery. There is no engine. So once you've let it go at the top of the hill, one thing's for sure, you want it to get back to the station and you want it to come back in at roughly the right speed. And when you consider that the speed on the track depends on the weather, on the weight of the passengers, on the temperature, on whether it's rained or not, there's a huge number of variables.
To ensure the car had enough energy to get round the track required careful mathematical calculations. And in the early days, the track then had to be tested. One coaster builder had a novel approach that wasn't much fun for his apprentice.
He literally would build the first drop and the second hill after that, and would build it a little bit too high. He'd then get the boy and strap him onto a roller coaster bogie, roll him round the track, mark the position on the second hill where it stalled and started to roll back, and then build that hill a little bit lower.
Once designers had really cracked the maths, tracks could be built higher and steeper. With steeper drops came accelerations that gave designers a new headache: G-forces. An accelerometer is used to measure the G-forces on a roller coaster. Sitting a passenger on one will show exactly how they affect a person's weight.
What we've fitted into the ride now is a set of 3 accelerometers. These are little devices which actually measure the G-force that's happening here. The information goes into a computer, and then we can immediately look at it afterwards and see the acceleration at every spot on the ride all the way round.
When the train arrives back at the station, the results provide an amusing insight into the forces at work.
What it's actually doing is telling you how much you weighed while you were on the ride. The ride starts over here, and you're weighing normal weight. And as soon as you go down the first drop, your weight doubles at the bottom of the first drop. And then it goes even higher. It's going up to 3 times your body weight. Nearly 200 kilograms is what you're weighing at that time. Everything below the line of 1, your weight reduces. So here you're only weighing about 30 kilograms or 20 kilograms.
It's these fluctuations in weight that help make the roller coaster such a thrilling ride. Too big a G-force, however, and it's a different story.
If you go to +6, +7G, then a number of the passengers will begin to have nosebleeds, their eyes will start bulging out of their sockets, and it really gets quite difficult for a number of the passengers.
It soon became apparent that roller coaster tracks had to be designed within the limits of human physiology. So, the search was on for new and exciting ways to thrill. In the 1950s, most coaster tracks were made from wood, but Walt Disney wanted to try something different. Enchanted by the Matterhorn Mountain, he wanted a themed ride that would replicate the thrill of a bobsled race. For the Matterhorn, it was clear to coaster designer Ed Morgan that using wood was not practical.
We're inside of a steel mountain, and it became obvious right away that we could not use wood. Well, for one thing, the fire hazard alone.
The solution seemed obvious. Angle iron had been used on some smaller rides. Surely it would work for the tight twists and turns needed for the Matterhorn. To bend a track, the angle iron is passed through a series of rollers. For a ride like the Matterhorn, the bend needed to be smooth. As the angle iron is bent more and more, it's not long before the bend begins to fail and buckles completely. So designers Ed Morgan and Carl Bacon had a better idea: tubular steel. And no matter how much it is bent, tubular steel still keeps a perfect curve.
Disney commissioned my father and Carl to build a test track out of the new materials. It was clear that the round pipe rail was in fact a far superior solution.
And within just a few years, Ed and Carl's team realized they could push tubular steel even further when they employed the skills of engineer Ron Toomer.
Carl wondered if we could build something, a track that does this, and he moved his arm through the air like that. And I said, "You mean like a corkscrew?"
When he first proposed it, we were all sort of like, wow, that's pretty radical to think about going upside down.
And for Dana, the ride's first guinea pig, it was an experience like no other.
There was a warehouse building directly ahead of the corkscrew, And I had the sensation that the building turned over twice, but the forces were such that I never felt like I actually turned over.
With tubular steel, the possibilities seem endless, and in the 21st century, it is unrivaled. With the track made from tubular steel, roller coasters can be pushed to even greater limits. And it's from the safety of the car that passengers can experience the thrill of a lifetime. Modern roller coaster cars are masterpieces of engineering. The wheels on early cars were made from steel, but these rides were slow and sometimes dangerous. So, how could rides be made safe and still include that all-important ingredient, a sense of danger? The roller coaster car is the culmination of 100 years of technological innovation. But in the beginning, if they went too fast, the car would fly right off the track. Until 1912, when engineer John Miller came up with a brilliant idea.
Well, here we are underneath the front car on the train of the 1922 Big Dipper roller coaster, which is fitted with these special wheels here. These are the upstop wheels, and when the car's about to lift off the track, when it's going negative gravity, this wheel connects to the underside of this piece of timber here, which is part of the track, and it stops the train coming off the track.
Now you can send the train through higher speeds, introduce moments of negative gravity when riders would feel that they're being lifted up off the seat of the car, but the car doesn't lift off the rails.
The roller coaster could now travel at speeds of up to 50 miles an hour. But steel wheels were noisy and bumpy. For Disneyland's Matterhorn ride, that wasn't an option.
For a themed attraction like the Matterhorn, where they were trying to give the impression that you're in a bobsled on ice, it would not have come even close to giving the correct sensation.
The design team needed a new material. And surprisingly, spoils of war from German chemical companies provided the answer. Polyurethane.
The polyurethane resulted in a much quieter and much smoother ride. So I think that was key to making that attraction what it is today.
For years, polyurethane remained the material of choice. Until the year 2000, when maverick coaster designer Stan Checketts and his team at SNS Power set about designing the Domper, a new ride in Japan that would break the 100-mile-an-hour barrier. But they had a problem.
One of the biggest factors back in those days was wheels not holding up and being able to take the heat and that at going that kind of speeds.
This wheel is an example of a blowout that can happen either from very high speed or very high load. And basically all the polyurethane that's in there turns to liquid because it gets too hot and it comes shooting out.
At 30,000 feet, Stan had a flash of inspiration.
I fly in a Learjet, I come down, the Learjet lands doing 150 miles an hour, I look at the tire this big around, duh, that must work, so that's why we use that.
So basically this is an airplane wheel off of a smaller airplane, and this is what allowed them to gain the speed record at 107 miles an hour.
And with speed come more death-defying stunts, and the harness becomes an essential. But the harness isn't always needed for the reasons you might think. There's another force at work.
Centripetal force is that strange force that holds you in your seat when you're on a roller coaster going upside down through the loop.
This force is strong. Take a glass of water on a loop-the-loop, and you can see what happens. So restraints are for when the unthinkable happens. On the Demon roller coaster in Chicago in 1998, riders were trapped upside down for 2 terrifying hours. Restraints saved people's lives that day, but the roller coaster is really very safe.
Statistics indicate coasters are safer than playing billiards, safer than using toothpicks. They're one of the safest forms of transportation you can imagine.
Now, with the foolproof restraint, engineers can design cars previously only dreamt of. Suspended, standing, flying, and now with X, spinning. With inspired engineering and boundless imagination, the roller coaster car is surely one of the safest, most exciting places to sit. Think roller coaster, and one sound immediately comes to mind. And it's the launch where it all begins. For the first 75 years, a ratchet and pulley system was the way every ride was launched.
This is the lift hill on the ride, and it's where the energy is given to the roller coaster train. The chain is driven by an electric motor, and it pulls the train up to the top of the hill and then lets it go.
And it does more than just get people to the top.
Most traditional roller coasters set the scene for the ride, and as you climb closer and closer to the top, it makes you wonder for a moment, what am I doing here?
Then in the late 1970s, parks looking for the next big ride wanted something brand new to excite customers. For legendary German roller coaster engineer Werner Stengel, this was an enticing challenge.
The parks are asking, what can we do different? And this was the reason to introduce the launch coaster. It's a different coaster. The feeling, the excitement to be accelerated in 4 seconds.
To achieve this sudden acceleration, Werner Stengel needed an efficient way to create energy. The first rides used a ballast weight.
He had a large weight which was hooked by cable to the front of the coaster train. That weight was dropped and it pulled the train out of the station, going from 0 to 40 miles an hour within 4 seconds.
Werner soon discovered a more effective method. A flywheel could store energy like a battery and release it in large bursts, driving the gears, which then turn a series of tires attached to the track.
Underneath the train we have a drive fin, and this fin is in between the 2 tires, and we, by friction, bring all the forces to the train so we can accelerate the train and we can decelerate the train.
The tires grab the fin and propel the train out of the station. Soon, other manufacturers followed, but mechanical parts meant these launch systems wore out quickly. So in the mid-90s, amusement parks turned to a different system. And surprisingly, it was similar to a technology found in most homes.
This is the stator of a conventional induction motor as used on a washing machine.
Inside the stator is an arrangement of copper wires. When powered by electricity, they generate an electromagnetic field that moves in a circle and drives the rotor.
When we make a linear motor, we effectively put a cut along that and open it out flat.
And now the electromagnetic field runs in a straight line. The motor is covered with a resin to protect it, and the rotor is replaced by an aluminium fin. And the power is turned on.
And as we increase the power to the motor, we begin to see that the force increases on this, and the fin is now trying to move in this direction, and I'm having to restrain it. And if I let it go, it accelerates away.
In 1995, Alan Foster was approached with an offer.
A phone call from Premier Rides in the USA, who had a requirement to accelerate a roller coaster vehicle to 55 miles an hour
in a distance of about 50 or 60 meters.
Within a couple of weeks, Premier were back with a check and an order.
Whilst we were very pleased with that, we were also very worried. We needed to prove to ourselves that this was going to work, and so that's the time we decided we must build a demonstration track.
For the test track, pairs of motors were placed opposite each other with the fin in the middle. To Alan's delight, it surpassed all expectations. The ride, Flight of Fear, opened in 1996 and thrilled riders by accelerating from 0 to 50 miles an hour in 4 seconds. Anticipation was now replaced by sheer exhilaration.
You don't have that moment to consider your fate on a launch coaster because there is no slow spot at the beginning.
For Stan Checketts, these new speeds were still not fast enough.
We wanted to break the 100-mile-an-hour record. We wanted to be able to take a roller coaster and go past 100 miles an hour.
It was then they looked to a system used in their tower rides. Air launch.
An air launch system, pretty simple. You take a compressor, you pump up air. Pretty simple. You put that in an accumulator, a storage tank, okay? Then we take that air and we put in a cylinder with valves. Once that goes into that cylinder, that pushes that piston, just like in your car, it's pushed with gas, we push it with air.
And it thrusts the riders out of the station at astonishing speed.
That way we was able to achieve in Japan, Dodonpa, which goes from 0 to 107 miles an hour in less than 2 seconds, and therefore achieved a complete roller coaster circuit at over 100 miles an hour.
These new launch systems mean that the sky is the limit. Modern launch systems have given us coasters that can accelerate over 100 miles an hour in mere seconds. It makes for an exciting future. With parks constantly competing against each other, records will continue to be smashed.
The arms race of tallest and fastest will always be a huge issue, even for each type of coaster. So the next coaster that we design like X, I'm sure the customer will want it taller and faster.
We have the technology today to build a coaster of any height or any speed. As far as I'm concerned, they can fly me to the moon and drop me back to Earth.
Pure theatre, pure drama, and that's what makes a roller coaster great.
Na de reclame neemt Chris Berry ons mee aan boord van een paar reusachtige vrachtvliegtuigen in zijn nieuwe serie Massive Machines.